Hello friends, I am Nikita and you are watching Prepare for Tea. Today, the content of our discussion will be on filters and oscillators. We will be discussing active filters, sinusoidal filters, criteria for oscillations, wave shaping, 555 timer. Moving with the active filters, filters are analog devices which filter out particular band of frequency or passes specific set of frequency according to their characteristic traits. Usually transfer function helps in knowing the characteristic of a filter. Our transfer function is a mathematical form where the numerator defines the set of zeros and denominator the set of poles. Often the pole can be either real or complex conjugate. Here I would like to show you that we have an S-plane. In S-plane, this is sigma and this is j omega. Mostly, it is likely to be considered that all the poles should lie on the left hand side of the j omega axis, making the whole, or on the real axis, making the system stable. This could be there could be the first order or second order filter. Few filters that we listed below are low pass, high pass, band stop, and all pass. Earlier we have discussed that an integrator is a low pass filter. It passes all the low frequency and stops all the high frequencies. A differentiator is a high pass filter. So basically we are applying our amplifier calculations of integrator and differentiator in finding the low pass and the high pass filter and other filter. Let's look further what are the different characteristics or transfer function of these filters. Now the low pass filter. Low pass filter, first order and second order filter. The first order filter has one pole. This is one pole. Okay. It is a quadratic equation. The second order means it has a quadratic equation. It has two poles. The high pass filter not only has one pole but has also one zero at zero. The high pass filter has two poles and two zeros. Here the zeros will be on input. Now the all pass filter. The all pass filter has a real zero and a pole. Similarly, the second order has two real zeros and two poles. For the band pass filter, the first order doesn't exist because it has to have two frequencies, a high frequency and a low frequency, because it is almost like a band. It should have H and F of L, right? To make it show it characteristic, that is the band pass. So